In this video we're going to go into a little bit more detail about some of the features of the SketchUp import into VCarve Pro and Aspire. We're going to start once again with Eric's model here in SketchUp, and we're going to just look at some of the details that present challenges for the manufacturing. If we switch to the skeleton view and zoom in here, we'll see that there's a lot of these joints where we have the cross beams come through into here. If we just select these cross beams, we'll see that there is absolutely no clearance where they intersect through the wooden beams. There's also completely square corners here. Obviously, when we come to CNC machine these, there's going to be variations in material thickness, and also the cutter is going to leave a radius, a fillet in effect, in these corners, because with a round cutter on a CNC machine you can't create a completely square corner. And the normal process for handling this is to add what's called Dogbones, where we create a little fillet radius here so the tool can move into there and leaving enough space in the corner for the parts to be assembled. Equally, to make sure to account for variations in the timber that you're cutting it from, it's normal to leave a gap here, an allowance all the way around these parts. Now you can do this in SketchUp, but the problem there is that once you've created these allowances and if you decide to move any of these parts, it's much more difficult to move the associated slot because it no longer lines up exactly with the part that is going through the slot. The other interesting things about this model is that it's making heavy use of components. So rather than these cross beams, if we just select down to these cross beams, rather than these cross beams being a single piece, if we go in, it's actually made out of a central section, end sections, of which all the ones in the model are exactly the same, and even these little tabs up here are all components. Obviously when we import these into VCarve Pro, we don't want to cut all these things individually. So therefore, but equally these are part of a larger component. So what we've developed is a naming system to allow us to say at which point we want to treat a component as an indivisible part. And the way we've done this is if we look at the inspector here, so modeling entity into, and we select on here, this component's name has been modified to start with 2 underscores, and you'll see on the import into VCarve Pro that we can use this as a trigger for telling us that so we want to divide the model this far but no further, and that this component is going to be treated as a single entity. So if we looked further inside this and click on this component, for instance, you'll see it's S-joint is its name, but it doesn't start with that double underscore. The other little bit of intelligence we've added to the model is the ability to find what is the actual front face for a component where it might be ambiguous. By default, VCarve Pro will take these components, look for the largest face and assume that, and lay it down flat, assuming that's upright. And for the vast majority of cases that does work correctly. But we also let the user override this in cases where that might not be the right answer, or where sort of the front and the back of an equal area, but sort of there's features on one that sort of means that one it needs to be cut with that face upwards. And we do that by allowing you to specify a particular material. So if we look at window materials, and what we have inside this is this front face material. So any place that's been painted with the front face, we would know when we import it that that's the one that we want to have at the front. And if we look back, so on these spars, only the one face has that material. Okay, so if we switch now over to VCarve Pro, we'll go through the import process again, and we'll go into a little more detail and pick up on some of these features. So swap into VCarve Pro. Once again, we'll create a new file. We're going to cut these out of 8 foot by 4 foot sheets and 3/4 of an inch thick. So we hit OK, and our first step is to import that file. So there it is, exactly as it was. Right, so over here we see this exploded flat layout, and we've got this orientate by material, and this will show us a list of all the materials that are currently in the model. And here we've picked that front face, and so If the part component we're looking at has a face of that material, we'll use that for orientation. If it doesn't, we'll just fall back to our default of selecting the largest face by area. A gap between the parts. We won't go over the three views at the moment. As I mentioned in the previous video, SketchUp represents circles and arcs as a polyline representation. We can examine the model for these and refit them to make them true circles and true arcs in boundaries on import. Now this section down here is the part that controls how we take apart the model when we import it. We're going to have the option here to create a group for each component in the model when we bring it into VCarve Pro, and that's usually very helpful. It allows us to select any single part and move it around as one piece when you're inside VCarve Pro or Aspire. This is the option for keeping those parts with underscores together. When this is clicked, by default, if it wasn't checked, we will go down to the lowest level of component inside the SketchUp model and split it out and treat it as a separate part. By adopting this naming convention for our components in the SketchUp model, we can tell VCarve Pro to stop taking the component apart to that spar we saw. Once we reach that with its name, start with double underscore, we know that that should be treated as a single component. And this is another very important option for this sort of construction. If you remember back in SketchUp, we had the spar made out of a number of separate components. Well, each of those will have a separate boundary when they're imported. Obviously for cutting out, we would like that to be a single boundary all the way around the part to be cut. So this option will try and weld all the component boundaries together on import so that we have a single machinable boundary when it's imported into VCarve Pro. Over here we're going to switch off the corrugated roofing again because they're obviously not going to cut on the router, and also cut off the entourage with the cats and the bricks, and hit OK. So this again is importing the SketchUp model, laying all those components flat, but only subdividing them down to the level where they start with those double underscores in the component name. And so if we look up here, this component, F7, is one of the main beams on the model. And this part up here, the S-joint so-called, it was a component. Each one of these little tabs was a separate component. And what we've done on this import is weld those all together to get a single boundary. We've also respected all the layers of all these parts as they came in as well. And again, that's very important, as we'll show, for automated machining of these parts. Now if we go back to the drawing, so we've laid these out in a roughly rectangular fashion. So I'm going to select them all again and go to our nesting. We're going to be cutting these out with a 1/4 inch tool. So 1/4 inch tool for the tool diameter, small clearance additional on it, and we're just going to hit preview. So the software now is looking at all the parts and trying to minimise the amount of material used for laying these all out on 8 foot by 4 foot sheets. And you'll see in a moment when it's finished calculating that it will lay these out onto 52 separate 8 foot by 4 foot sheets. Okay, so here's the default sheet that we're cutting, so we can click on any one of these and it moves it down so we can examine those in more detail. We can also control which sheet we're looking at in the main view by clicking on here, and then we can just circle through all these. So if we look at these early sheets, we've got a number of features on the material. They have these holes on here. They also have these interior slots. We've got these text, and we've obviously got the outer joints. We've got components that are these pegs and wedges, and each sheet has a different mix, and so the later sheets will tend to just have a single sort of part. So these later sheets don't have any pegs and wedges, and we'll see what this means for the toolpaths when we come to that in a second. So what we want to do with these, if we look at sheet 1, let's just zoom that. Sorry. So if you look at sheet 1 now, this has holes, slots, we have some text here. I'm just going to ungroup all the vectors on this layer and we'll see them now. So if I click on this, you can see down here this is on the text layer. If we click on these holes over here, we can see down here that these are in a layer called screw holes, and then we also have pegs and wedges on separate layers over here. And what we're going to do is apply a toolpath template that uses this layer information to automatically select each vectors and apply the appropriate toolpath. So if we just show what that involves, we switch over to Toolpath tab in VCarve Pro, and I'm going to load manually the toolpath template. So again, templates, this is a one we've set up here, 18, please. And at the moment it's going to tell us that there's a layer missing called Dogbone toolpaths. I'll come back to that in a little while when I show that, but for now we're going to create that missing layer just to load this toolpath, and we'll just look at the other three cards. So if I look at this text toolpath, this has been set up in advance via profiling toolpath, and as you can see when I've clicked on this, it's selected everything that is on the text layer. We're going to use a 1/4 inch end mill, we're going to cut to 0.1 of inch deep, and if we calculate that, we'd see here on the preview, and I could preview that and it'd show that we've cut out that for that toolpath. If we go back to our 2D view and look at the drill screw holes, when I've clicked on that, it's automatically selected all these screw holes, and we've associated drilling tool into drilling toolpath. Again, these are marker holes for screws, so we're just drilling to 0.1 of an inch deep. And the reason that it's automatically selecting all these vectors is that down here we have this, what we call the vector selector for the toolpath. So I click on that. This allows us to automatically associate vectors with the toolpath, and what we've said is that for this toolpath we're going to select all closed vectors on the layer called screw holes. I'm going to associate it with the toolpath. So now whenever this template is loaded and calculated, it automatically selects those vectors. If we look at this one for profile pegs and wedges, this is a 2D profile toolpath. It selects all the components on all the vectors on the layer pegs and wedges. But this is a little bit interesting as well, is it's set up so its cut depth is Z, which is the material thickness, plus 0.002 of an inch. So that means we can easily change our material thickness, and this template will stay appropriate. It'll always cut through 0.002 of an inch to make sure we've cut out our parts. So we just delete these toolpaths for now. We'll show the automatic application of these toolpaths to our part. But the other thing that I'd point out is that the slots for assembly, we've said, are to the exact size that they've been designed in SketchUp. Well, that is not going to allow us to assemble our parts. We're going to have radius on the inside of the corners. So we do a simple toolpath to show this. So we create a profile toolpath. We've got our 1/4 inch end mill here. We're going to calculate inside, and we'll just select this vector here to show it. So calculate that. So if we preview that toolpath and we zoomed in, you'll see we start to get rounded edges. This is easier to see in the 2D view, so if we turn on the solid preview and zoom in and switch on the visibility of toolpaths, this shows the shadowing effect of the tool. And here you can see that in these corners the tool won't cut straight into the edge. And what that means is that when we bring in our other piece to push through there, it just isn't going to fit. So let's delete that toolpath and we'll show you how we deal with this. So we still have all our 52 sheets, and what we're going to do now is run a gadget that Vectric have written especially called Dogbone Toolpath Creator. And what this will do is find all the vectors that are on this layer 0, which is all the outer profiles in the way the model's been constructed. It's going to say that we've got a tool diameter of 0.25, and also these slots really need an allowance on them to allow the parts to fit through, and we're going to put that at 0.008, so 0.008 of an inch we're going to add just to the inner slots. The outer profiles are already at the right size. If we hit OK now, what this will do now is identify all those inner slots and add allowance for us. It will identify all the interior corners where we get those fillets and put in what we call a Dogbone. So we come back to our sheet here and zoom in. What this has done is in all of the external corners, it's identified and marked with these little circles for ours where the tool would not fit in, and then it's put in this, it's created a vector which we can use as a toolpath with this extra little move, so the tool will come down here and move along this, forming a little notch there, so that when the pieces are assembled. Now this will be much more visible when we create the toolpaths in a minute, and equally the allowance that we've generated on the slots will also be much more easy to see from the toolpath stage. So what we're going to do now is that template that we created earlier, we're going to apply that template to all 52 sheets. So we go up here, apply template to all sheets. This is a standard gadget that Vectric supply and is available from gadgets.vectric.com. So if we look at the layout of this form, what we've got here, we've got the template file, and we're going to pick that template that I showed earlier that has the 4 toolpaths for doing the outer border, doing the text, drilling the holes, and also cutting out the pegs and wedges. We've got this option checked here, save toolpaths after calculating. And what this means is that once we've calculated the toolpaths for all 52 sheets, we're going to post-process them. So that is change the instructions for the machine into the specific dialect that is used for the CNC machine tool you're going to cut them out with. Now, there are lots and lots and lots of different languages used by CNC machine tool. As you can see, VCarve Pro and Aspire have a huge selection to choose from. In this case, we're just going to go with a very generic G-code arcs and support for a tool changer. And down on this section here, we select the output folder. So this output folder is currently empty, as we'll show by here. So this is the output folder for the toolpaths. So if we go back to our gadget now and we hit OK, this is now cycling through all the sheets in the toolpath, all 52 sheets, loading the template and creating those 4 toolpaths. Now some of those sheets do not have all the features. The later sheets don't have any of the pegs and wedges. Some of them don't. Later sheets don't have those toolpaths for the drilling. So if we look here, we've got this report. It says that for sheet 1 we've calculated all 4 toolpaths OK and saved it out, all 4 toolpaths, into one toolpath file ready for the machine tool. If we come down here to some of the later sheets, it says that there were no drill screw holes, there was no profile and wedges on those, so it didn't create those 2 toolpaths, but it did create the text and the profile cutout, and this sheet had the 2 toolpaths saved. If we look over here on the right, we've got the list of all the toolpaths we've created, and if we go back to that folder that we selected as the output folder, you can see now we have here a toolpath for all 52 sheets. And these are just the instructions. If we look at it with Edit Notebook Plus, these are the instructions for the machine tool to drive the cutter to cut out our sheets. So we swap back to VCarve Pro. We'll have a look to see what that we've meant by that dogboning. So if we zoom in on here, and over here we've got this. We've got solid checked on here. So when we zoom in on our view, we'll get this representation of the toolpath. So this is the toolpath we machined along, and you can see here the toolpath has detoured off into the corners just to overcut it so that our square parts are going to fit into these slots. Also, if we zoom right in, we can see here we've got our 8 thousandths allowance on these interior slots, which will give us our assembly allowance for the parts. Now, as we mentioned, the outside of these profiles did not need this allowance added. So if we zoom in on those, and we can use the zoom tool from here. So if we look at the outside, this is exactly to size. We're cutting directly up to the edge of the part, but we're still putting in the dog bones in the corner so that we can still assemble these parts with the other parts. Okay, so there we have it. We've created all the toolpaths for all 52 sheets. We've created dog bones for all the parts. We've allowed for allowance for the internal slots, and again, so if there's variation in the material thickness, we can account for that by increasing that allowance slightly. And there's been no human intervention, no opportunity for mistakes. We've also importantly created the outer boundaries, single outer boundaries for those components that were actually created for multiple components. So that's it, and thank you very much for listening.